When you look up at the night sky, you see thousands of bright stars. But have you ever wondered what these stars are? How did they form? Why are they so different in color and size? And most importantly, is the sun just an ordinary star? In this episode, we'll take you on an exciting journey through space to discover the secrets of stars, including our closest star, the sun. Welcome to your channel Beyond the Stars. Today, let's learn about everything related to stars and the sun. Stars are huge balls of glowing gas composed primarily of hydrogen and helium. They act as giant nuclear reactors, fusing hydrogen atoms in their nuclei to form helium, releasing tremendous energy in the form of light and heat. This process, known as nuclear fusion, keeps stars glowing for billions of years. Stars go through different stages of evolution, starting as gas clouds known as nebulae, then collapsing under gravity until nuclear reactions begin and finally becoming stable stars. When they exhaust their fuel, they can transform into red giants, neutron stars, or even black holes depending on their mass. Some stars live only millions of years, while others live tens of billions of years, making them the oldest objects in the universe. Stars vary in size, color, and age, and can be classified into several types. Red dwarfs are the smallest and coolest stars, living billions of years. The most famous of these is Proxima Centauri, the closest star to us after the sun. Although these stars are dim, they are the most common in the universe. Main sequence stars, like our sun, remain stable for long periods and produce constant energy. This category includes most of the stars we can see with the naked eye. Blue giant stars are among the hottest and brightest stars and can be hundreds of times more massive than the sun. However, they burn out quickly, ending their lives in massive explosions, known as supernovae, which release energy equivalent to hundreds of billions of times the sun's energy. Red giants are dying stars that expand dramatically before collapsing into white dwarfs or exploding. Betelgeuse in the constellation Orion is an example of a red giant nearing the end of its life. Neutron stars and black holes represent the inevitable end of some massive stars, collapsing in on themselves with such extreme density that they become objects with such immense gravity that even light cannot escape. The sun is a medium-sized star at the center of the solar system and is the primary source of light and heat on Earth. It is approximately 4.6 billion years old and is composed primarily of hydrogen and helium, with small amounts of other elements such as oxygen, carbon, and iron. Its diameter is 1.39 million kilometers, 109 times that of Earth, and its mass is 333,000 times that of Earth. It accounts for 99.8% of the mass of the entire solar system, making it the primary factor that maintains the stability of the planets in their orbits. The sun consists of several main layers. In its core, nuclear fusion reactions occur, where hydrogen atoms are converted into helium, releasing enormous amounts of energy. The temperature of the sun's core reaches about 15 million degrees Kelvin, making it the hottest and densest part of the sun. On the sun's surface, known as the photosphere, energy is emitted in the form of light and heat, with temperatures ranging from approximately 5,500 to 6,000 Kelvin. The photosphere appears grainy due to the movement of hot gases and sunspots, which are relatively cooler regions due to magnetic disturbances, can be observed on it. The solar wind is a constant stream of charged particles emitted by the sun, moving at speeds of up to 800 kilometers per second. When they interact with Earth's magnetic field, they cause the aurora borealis, which appears as spectacular lights in the polar sky. Occasionally, massive explosions known as coronal mass ejections, CMEs, occur, sending billions of tons of plasma into space. If they impact Earth, they can damage electrical power systems, satellites, and even disrupt global communications networks. Screenshot of the sun expanding into a red giant. The sun goes through a life cycle like any other star. In about 5 billion years, it will exhaust its hydrogen fuel and begin expanding into a red giant. This will expand to the orbit of Earth or even Mars, evaporating nearby planets and possibly destroying Earth entirely. At this stage, the Sun will begin to lose its outer atmosphere, transforming into a planetary nebula, leaving behind a dense core known as a white dwarf. This core will gradually cool over billions of years until it becomes a black dwarf, a cold object that emits no energy. The Sun emits energy equivalent to 3.8 times 10 to the 26 watts per second, enough to meet humanity's energy needs for millions of years in just a fraction of a second. The light emitted from it takes approximately 8 minutes and 20 seconds to reach Earth, meaning we see the Sun as it was in the past, not as it was in the present moment. The Sun orbits the center of the Milky Way galaxy at a speed of 828,000 kilometers per hour, taking 225 million years to complete one orbit around the galaxy. The Sun is not the largest star in the universe. There are stars hundreds of times larger, such as UY Scuti, which has a diameter 1,700 times that of the Sun. However, our Sun remains the most important to us because it is the source of life on Earth. Since time immemorial, stars have been a source of inspiration for humans, guiding travelers, arousing the curiosity of scientists, and revealing the secrets of the universe. With each new discovery, we realize that we are just a tiny dot in this vast space, but we are also part of this great universe. The atoms that make up our bodies may have been born in the heart of a star that exploded billions of years ago. If you enjoyed our journey through the stars and the Sun, don't forget to support us with a like, subscribe to our channel, Beyond the Stars, and activate the bell so you don't miss any new journeys into the secrets of space. Write to us in the comments. What surprised you most about the stars? And do you have a favorite star? We await your opinions. See you in the next episode of Beyond the Stars.